Namaskar. I am VIKRAMSINGH CHAUHAN, PGT Physics, Nanvidyaniketan, Jamnagar. Welcome you all. Till now, we had discussed the linear motion of an object. The object was moving along a straight line, and we had described its related terms, the terms which were related to the motion of the object, like its speed, distance, velocity, displacement, acceleration, and so on. Today, we are going to study a special type of motion which is not similar to the straight line motion or rectilinear motion. For example, suppose a thread is there, a thread of certain length L is taken, and an object is tied to the thread. Then holding this object, if this object is rotated like this, the object revolves around the axis, which is my hand, and the object moves along a path which is not linear path, it is circular path. There are different situations where we come across the motion of the object is not linear but circular. Like our fan, when the fan is switched on or switched off, it rotates about its axis, the central axis. When an athlete is running in his competition around a circular track, then he covers distances on the circular tracks, maybe in equal interval of time or may not be in the equal intervals of time. When an object is taken and it is tied to a thread and rotated like this, the motion can be called as circular motion. Motion of hands of clock. Suppose we are having a clock like this, and if we talk about the motion of the second hand, minute hand, or the hour hand, they keep on revolving around this axis. About the axis, the central part, the main part of this will be the axis. So if the tip of this second hand is taken into consideration, the tip of this second hand is taken into consideration, it will cover equal distances in equal intervals of time along the circular path. Such type of motion is called as circular motion. So we will define circular motion when an object moves along a circular path its motion is called as circular motion. Circular motion. As I said, the rotation of the fan, rotation of a spinning top, the revolution of the earth about the sun, revolution of the moon around the earth, even the revolution of the electrons about the nucleus, they are also in circular motion. So various objects, several things, they are in circular motion. Now depending upon the time that has taken for covering equal distances, suppose the time is equal, like a clock, this second hand covers equal distance in equal interval of time. Every time, that's why it will tickle 1 second, 1 second, 1 second, 1 second. In this way, it will shift entirely. It will cover the entire circular path in a fixed 60 seconds of time. Or the second hand will cover this much distance, this much arc, this much linear distance in 5 seconds. So circular motion occurs in different situations. If the distance covered along the circular path is equal in equal intervals of time, then we call it as uniform circular motion. And if the distances covered are not equal, then we call it as non-uniform circular motion or only circular motion. When the fan is switched on, the motion of the blades of the fan is not uniform, because the fan blade will go on increasing, the distances covered by the fan blade will go on increasing. That's why the motion will not remain uniform circular motion. But once the fan attains a certain speed, that time in each second, in each interval of time, equal intervals, equal distance will be covered by the fan blade, So let us think about a simple example. Consider an athlete is running along a rectangular track. So if the athlete is starting from point A, he will have to change his direction at point B, at point C, at point D, and at point E. If the athlete is running like this, when he will come at point B, he will have to change his direction for running. In the same way, at C, at D, and at E, at these points, he will need to change his direction. Now let us increase the number of sides of this diagram, say, or the track, say. So if the track is now like a hexagon, if the track is like this, then we will have a point A, B, C, D, E, F, G. We are having, this is not the G, H. Suppose the track is like this. So the athlete will have to change his direction at all these points 8 times in this path. This is not the hexagon, but still we can take the path, circular path is the rectangular path is modified in a polygon in which we are having sides 3, 6, 8, octagon. Now this means at each point the direction will have to be changed by the athlete. Then and then only he will be able to cover this entire path. In this way, suppose if we went on increasing the size of the polygon, we will reach nearby to a circle, and the direction of the athlete will you will have to change at each point on this circular track. Although the speed, the magnitude of velocity is constant, the direction of the object continuously keeps on changing in circular motion, and that's why in uniform circular motion we call it as it is an accelerated motion. So I guess you are clear with this part. If an object is moving along a circular path with constant speed, like the fan at a constant speed, so at that point, in that case, at each point along the circular track, the direction changes, and that's why we can call this type of motion, we can call uniform circular motion as the accelerated motion, because the direction of velocity is changing, not the magnitude but the direction is changing. So let us write uniform circular motion. We will define uniform circular motion. Circular motion of an object with constant speed is called as uniform circular motion. We can also write it as UCM, can be pronounced as uniform circular motion. As the direction of velocity of the object in uniform circular motion changes at each point of the circular track. The uniform circular motion is considered as accelerated motion. This acceleration in this case, in case of circular motion, is a special type of acceleration whose direction is always towards the center of the circular path, and that's why this is called as centripetal acceleration. Centripetal acceleration. But at the instant we will not consider this part. Centripetal means center seeking. But that much only you will need to remember. Now consider the motion of an object along this circular path. Let us take the radius of this circle is r. Let the object is starting from point A. This is the velocity of the object, and at each point the object is moving anti-clockwise sense. If the object is moving along this part, so if the object covers object covers, I'll take it, object completes n rounds in time t, then speed is given by distance covered, distance covered in n number of rounds divided by total time. Thus, V is equals to, we can write n times the circumference of the circle divided by the total time is t. That is, V is equals to, we get n into 2 pi r upon t. This will be the small t. In uniform circular motion, the speed of the object is given by V equals to n times 2 pi r, where n is the number of completed rounds, r is the radius of the circle, and t is the total time taken by the object to complete n number of rounds. Suppose, I am telling this part, suppose the object is completing only one round. Then this will be a special case. The time taken to complete one revolution, or you can take rotation, one revolution is called as time period of revolution, and it is denoted by capital letter T. Thus, in one round, the distance covered S is 1 into 2 pi r, that is 1 I had used for n, so S is equals to, we are having 2 into pi into r, and thus speed is given by distance upon time. For one revolution, we can take it as speed is equals to 2 pi r upon t. That is, V is equals to 2 pi r by t. Note down the difference between this capital T and small t. This is for total number of times, this is for total number of turns or rounds, and this is for only one round. Also, the factor 1 upon t is called as frequency of revolution. Frequency, its SI unit is hertz, so we can write frequency nu is equals to 1 upon t, and thus velocity will become, speed will become V equals to 2 pi r nu. Try to write the letter nu, which is generally used for frequency. You practice it twice, thrice, 4 times like this. So we can come across the formula V equals to, you stick with this formula, V equals to N times 2 pi R by T. And for one revolution, this will become V equals to 2 pi R upon T, where R is the radius of this circular path. Let us solve some questions based on the same. Let me give you a question, a very interesting question. Like the clock that we had shown to you, this second hand is having length of 10 centimeter. If I will ask you what is the speed of second hand, we can calculate it. We can use this formula because we know to complete one round, the tip of second hand will take 1 minute, that is 60 seconds. So let us solve this. See, what is the speed of tip of second hand of length 10 centimeter in a clock? Let us solve this. Here n equals to 1, so t is equals to t is equals to, this will become 60 seconds because the second hand will complete one round in 60 seconds only. Thus, speed of the tip of second hand will be equal to V is equals to 2 pi R upon T. I'll write down the values, 2 into pi, 3.14 I'll take. R is given to us centimeter. So write down 10 centimeter as it is, divide by time is 60 seconds. So let us multiply or divide it. This will become, this 0 and this 0 will cancel out. 2 3s are, so we will get 3.14 upon 3. V is equals to, this will become 1 point. V is equals to 1.04 centimeter per second. This is the speed of a second hand of the clock whose length is 10 centimeter. Let me just once again show you this part. This second hand, the tip of the second hand will move with this speed. But if we will go gradually towards the axis of rotation, the point which is coming on the axis, it will remain at rest. This is a very important point here. Like I'll show you. Consider this is the circular path and consider a point A here. A is exactly at the last, means it is coming at the last of this circular, this disc say, and if it is rotated, you can see this A completes certain rotations, the number of rotations we can count, but this will move with maximum speed. This point A will move with maximum speed. Point A will move with maximum speed, and if we will come towards the axis of rotation, all points which are coming at the axis of on the axis of rotation, they will remain at rest. So in this way we can find out the speed of the point A. It will become the 2 pi r upon the number of rotations occurring in a given time t. So this is what the part is there. I hope you have understood the concept of circular motion. I am having one question for you as a homework. Just let me write it here. A fan completes 240 rounds in 1 minute. The radius or length, you can consider length of the blade. The radius of a point on its blade is 1.5 meter. Find number 1 the time period, number 2 the frequency, number 3 speed of the fan. So this is the question for you. I hope you have understood the concept of circular motion. Try to solve this question and try to solve the questions which are given in your textbook, in your reference books. This is a very simple concept where we will always need the formula V equals to N times 2 pi r by T. V equals to N into 2 pi r by T. This is total time. These are the number of turns of rotation. So this was the last point of this chapter called motion. I have tried to cover most of the things which can be delivered to you in a simple manner, in a precise manner. Hope you like this part, like the videos. Thank you very much.